Yeah, good morning, everyone. Good morning, sir. This is Dr. Neha Gulal, and me and Mitanshi, we are together presenting this paper.
Um, are you ready to start your presentation?
Yes, ma'am, yes.
Can we start the timer?
Okay, can I start?
Uh, yes. Just a second. Yes, you can start.
Okay, ma'am. Very good morning to everyone present here. Today, me, Dr. Neha Goel, and my colleague, Ms. Mitanshi Rastogi, um, we are presenting our paper titled Predicting Air Pollution, a Smart Step in Pollution Management. We have, as we all know that we are advancing in the field of science and technology, and we are moving ahead and ahead in every field these days. But we all know that with every good thing comes a bad thing. So as we are progressing in the field of technology, we are also playing with the environment these days. We all know sustainable development is in great demand these days. And because, as we are advancing in technology, we are coming up with various types of problems like the pollution is rising and the ozone is depleting and, or it is overall making an impact on the environment. So the impact on the environment is very, very crucial and it needs to be studied. So in this particular paper, what we have done is we have taken the AQI level, PM 2.5, and we have seen that pollution is increasing these days. The AQI level is increasing. Although the government is taking necessary actions every time, but then still we are not able to curb the AQI level at any cost. So I suggest that in case we are aware about the AQI level, why is it increasing, and if we are, if we are aware in the beginning itself, we can definitely work on the preventive measures. And if the preventive measures are taken, the world would not be suffocating for all of us. So, curbing this particular thing, there are two things which are there. The two technologies which are in great demand these days. One is IoT and one is machine learning. IoT requires sensors. We all know that. So here, what we have done is we have taken machine learning, and with the help of machine learning algorithm, we have analyzed the PM 2.5 AQI index, and we have suggested what preventive measures can be taken in our particular field. The details and the literature review would be covered by my colleague, Ms. Vitansh. Thank you.
Good morning, everyone. In the literature review section, different authors have covered about the growth and advancement in the smart city. And with this growing stage in the smart city, we are also growing in the pollution levels. The PM 2.5 level is increasing day by day. Different authors suggested different technologies, the author Mr. Serger has suggested that WASP Note, along with the wireless sensor using IoT technologies, helps in measuring the PM 2.5 level. And different authors suggested different techniques, like BP Pandey suggested GNB, KNN, random forest, SPM, XGBoost, different machine learning technologies to measure the level of PM25 well in advance so that we can take preventive measures. Next, the methodology. In this section, we collected the data set, then implemented the data set on machine learning techniques, and then computed the result. The data set of AQI level, we have collected it from Kaggle.com. It is a secondary data set which consists of 6 attributes having timestamp, year, month, date, and PM 2.5. This data set is from 2017 to 2022. And PM25 here signifies pollutants micrometer size. This is the screenshot of the dataset that is gathered from Kaggle.com. Since there are no missing values and the dataset is complete in every aspect, So we don't require any special pre-processing technique as such. So we have implemented our random forest machine learning technique for this particular paper because it can handle unbalanced data, and it is very much appropriate for nonlinear data sets as well. So to apply random forest machine learning technique, the performance analysis parametric measures are accuracy, recall, F1 score. For random forest, accuracy level is 88%, recall value is also 88, and F1 score is also same. In the results section, we have plotted the graph in which we have shown the tremendous growth from year 2017 to 2022. This is the level of AQI index increasing every year. And this graph, we have shown the correlation analysis of each component with one another. Like in x-axis, we have plotted year, month, day, hour, and PM 2.5. And in the y-axis also, we have plotted PM 2.5, hour, day, month, and year. So here we have seen, we have tried to show that the correlation is where the values are very much closely bounded. It means the correlation is very high. And where the values are scattered, where the plots, where the dotted lines are scattered, it shows that the correlation is quite weak. In the conclusion section, we have concluded that the life of the individuals are very much affected by the pollution. It causes bronchitis problem, health problem, cancer problem, asthma problem. So it is very crucial. It is very deadliest for the human lives. In this paper, we have concluded that random forest performs gives a result of 88.5%, which is a good accuracy level. And in future, we can implement more machine learning techniques on the similar data set to have better results. Thank you.
Okay, now we can start about the question and answer session.
Yes, ma'am.
Hello. Audible?
Yes, sir.
Thank you, madam. It was a very nice presentation. And I have one small question. You have told only about the measured quantity of this PM 2.5 or so and its effects. So are there any other measured and measurable this one particulate matters that are being considered that will give rise to pollution related issues other than PM 2.5?
Yes, sir. There are other parametric measures as well, but in this particular data set, we only received 2.5, which is a secondary data set, so we can't do much about it. So as per this particular data set, we have only PM 2.5.
So basically, we have constrained ourselves in this particular paper, and maybe in the next paper, we can work on the other things, and we can easily compare that if we are taking this, we are getting the accuracy of this 88.5, let's say, and then if we take some other value, so basically what is more responsive? I mean, with the help of which data, we can get a better accuracy and we are able to predict them much better. So here we have restricted ourselves.
And we can take measures for carbon dioxide gas, nitrogen, hydrogen. So we can take those gases also to check the pollution level.
What could be the probable sources of these particulate matter 2.5, madam?
Sorry, sir.
The sources from which normally such particulate matter will be emitted.
So
The sources of particulate matters.
Gases released from the various vehicles.
Machines, electronic
Okay.
appliances.
Yeah. Okay, thank you. So,
Thank you, sir. Thank you. Thank you.
any questions?
Okay, ma'am, am I audible to you?
Yes, sir.
Ma'am, you have chosen the random forest algorithm, and
Yes,
the
sir.
accuracy of this algorithm is around 88%. And you said that there is some weak areas in which correlation is not good. So, is there any way that we can increase this accuracy for the correlation?
So we can try other machine learning techniques as well, and this is in our future scope so that we can increase the accuracy in our
So,
next.
you have chosen only the random forest algorithm. Why not the others or any one of the other methods which you
So
have?
as per the literature review, we have identified that random forest is very much appropriate for non-linear data set and for uh, uh, imbalanced data set. So that's why we have opted for random forest only.
Okay, okay. Thank you, ma'am.
Thank you.
Thank you so much.
Thank
Now I
you.
would like to invite the paper ID 105. Paper title: Assessing the Influence of Quality Control and Assurance on Aircraft Maintenance Turnaround Time Reduction, a Regression Modeling Approach. The presenter is Deepak Chandra. I would like to ask the presenter if they are ready with the presentation.
Yes, madam, I'm ready with the presentation. Just sharing my screen.
Should we start the timer?
Just give me a second. Let me share it first.
Yeah, sure.
Sometimes screen sharing takes time. Give me just a second.
Sure, sir.
Okay. So here is my screen. I'm ready, ma'am. You can start the timer.
Can you present your PPT?
Yeah.
In slideshow?
I think now.
Yeah. Can you start this timer?
Yes, ma'am.
Yeah.
So shall I start, madam?
Yeah, you can.
Okay. Good morning, ladies and gentlemen. My name is Deepak Chand Chandola. I am a PhD in aviation management student from Banasthali Vidyapeeth University. My topic, the research paper which I am presenting here is to specifically identify the significance of quality control and quality assurance in reduction of aircraft maintenance turnaround time, a regression modeling approach. My co-authors are Preeti Chandola, Kamal Jaiswal, Mr. Rajendra Prasad Kholia, Dr. Seema Verma, and Mr. Manoj Kumar. Objective of this research paper is to highlight the significance of quality control, quality assurance in aircraft maintenance turnaround time, and drive a quantitative equation model to measure their impact. Limitation of this study is focused on airline industry. So all the aircraft maintenance divisions operating within the airlines in the Asian region only are included in this study. Problem statement for this research is this paper is to evaluate the quality functions role in decreasing the aircraft maintenance turnaround time. Quality functions here means quality control and quality assurance both. A lot of previous studies are already done, which are most of them are focused on optimization model by utilizing the machine learning. But this research paper is going to search it by using the regression statistics and taking this study is based on the questionnaire survey based model. So it is going to give more accurate data. So we'll start with the brief background of aircraft maintenance. Aircraft maintenance is mainly governed by two types of regulation, Part M and Part 145. Part M belongs to CAMO. CAMO stands for Continuing Airworthiness Maintenance Organization. MRO stands for Maintenance, Repair and Overall Organization. MRO is the main concern here because these parties are performing the maintenance on aircraft. So what CAMO and MRO does exactly? So CAMO is the organization which define what kind of maintenance work to be done and ensuring whether this maintenance is done on time. Then this message, this work scope is being conveyed to the MRO. MRO means maintenance, repair and overall organization within the airline. Well, it is a division within the airline, or sometimes it is an independent unit. So these MRO divisions are performing maintenance on aircraft and producing evidence in the form of work orders compliance that the required maintenance advised by CAMO are already compliant. Then aircraft maintenance is mainly divided in two categories, line maintenance and base maintenance. Line maintenance mostly take care of minor or small activities, and base maintenance take care of major activities, major inspection, aircraft assembly change like landing gear change, engine change, APU change, or any major item. So here, based on the literature review, we identified that quality control detect and rectify errors during the aircraft maintenance work. It ensures the safety procedures are being followed, and it also ensures that material and tools used during the aircraft maintenance are approved. It's not like any common material or tool is being used. It should be approved as advised by aircraft manufacturer. And if there is any discrepancy and quality control team finds it like there is improvement is needed, they advise quality assurance for the improvements required. Then quality assurance team ensures that quality management system framework is in place. It is integrated with safety management system, and they assess and issue authorization to the aircraft maintenance personnel to perform the maintenance on aircraft. So here it's like all the people who are working on the aircraft, performing the aircraft maintenance are not the random people. They are properly assessed. Once, like after recruitment as well, they are being assessed and evaluated by the quality assurance team to issue the authorization. And once they get the authorization, then only they are allowed to work on aircraft. In addition to all three, the fourth important vital functions which quality assurance is performing is doing audit. Auditing are in two parts, announced and unannounced. This research paper have used a research methodology which follows a stepwise approach in which it starts with the problem statement followed by literature review. Based on the literature review outcome, a survey is designed. Then the survey is distributed among aircraft maintenance professionals within the airlines industry within the Asian region, and then data collection is performed and data analysis. The statistic of the research questionnaire which included over here is total 9 questions were included in this study, and questionnaire distributed among 5,000 aircraft maintenance professionals employed by airline within the Asian region. Total response received by us is 4651, which is making it a rate of 93.02% of response. Based on the regression statistic, we have used here multiple regression, and regression statistics. Before going to regression study, let me inform you about how we come to know about the 5,000 sample size. So 5,000 sample size came based on the confidence interval 99, like normal sampling techniques were used. Confidence interval 99%, population margin 0.5, margin of error 2%, and the population size is 10 lakh, 1 million. So based on that, we came to know that sample size of 4143 is needed. So we have make it round figure, we made it 5,000 and we receive 4651. Now, this questionnaire was divided into two parts. Half of the questions were demographic questions and half of them were for regression, like Likert scale based questions. So the demographic, after the analysis of demographic questions, it revealed that the gender distribution of the people who responded in the survey, it shows that 2931 male and 1720 female were participated in this survey. Then the demographic of experience, how much the experience they have, what kind of hierarchical position our respondents have. So we can see that majority of our respondents were between 6 to 15 years of experience. And out of 6 to 15 years of experience, the second column, you can see the most 4261 respondents were have taken already working in the management role. Then you can see the distribution, it quite normal. However, measure of our respondents were between 6 to 15. We also have respondents from 0 to 5 years of experience and 31 to 50 years of experience. Then the data analytics use response analysis based on the MS Excel. Cleaning of the data was performed. After that, simple regression was performed in MS Excel and evaluated the significance. In this study, we have used many variables. There is one dependent and 4 independent variables. Dependent variable is reduction of turnaround time, and independent variables of proactiveness of the quality control, inefficient quality control processes, quality assurance methodology, and quality assurance framework. So we have taken 2 questions from the quality control specific, 2 questions from quality assurance, and 1 dependent variable. Based on the regression statistics, this R square value is 0.6252 and adjusted R square is 0.6249. By seeing the adjusted R square, it shows that 62.49% of variation is in dependent variable can be explained by these predictors. ANOVA summary of my regression model suggests that significance value is less than 0.01, which is highly significant, with the F value of 1937.58. Regression coefficient summary here, the coefficient column at the first column, coefficient column, shows the data that proactive quality control influenced the aircraft maintenance, reduction of aircraft maintenance turnaround time at the BOS, followed by the inefficient quality control process, then the quality assurance method, then quality assurance framework, and the last one is quality assurance method. Based on the regression coefficient summary, we managed to drive a equational model, and here is the equation model. Y equal to 0.513x1 plus 0.238x2 plus 0.99x3 plus 0.110x4 and the interception value. So here x1 indicates the influence of proactive quality control in diminishing rework and turnaround time duration. X2 indicates that importance of addressing inefficient quality control processes for enhancement, and X3 indicates the value of quality assurance methodology. X4 indicates the role of quality assurance framework. So by seeing the equation, we can see that coefficients which is attached with the X1, X2, and X4 are influencing the most.
Deepak sir,
Yes?
your time is up. Can we begin with the question answers?
Yes, sure.
You can continue, please.
Okay, based on the outcome of this research study, these are the 4 outcomes. Organization need to focus on proactive quality control. They need to redesign their quality control process, and they need to enhance the quality assurance methodology. Additionally, they need to do reassessment of their quality assurance framework. So here is the conclusion. Conclusion follows the outcome that quality control and quality assurance plays a crucial role in reducing the aircraft maintenance turnaround time. So future scope of work, future researchers can use the IT, like they can do the more collaboration with the industry expert airlines, and they can they can suggest a quality assurance framework. So here is the finish. I have finished my
Should we start the question and answer session?
Say again?
Should we start the question and answer session?
Yes, please.
Hello, Deepak.
Yes, sir.
Okay, it was a very nice presentation with the regression analysis being implemented to your aircraft maintenance related issues. And I have 1 or 2 small questions.
Yes, sir.
Said that the scheme is implemented considering only the Asian regions or something like that.
Yes, sir.
Can't it be implemented all over the same scheme of things?
Yes, sir. It could be implemented because our limitation was up to Asian region, so we concluded that within Asian region. However, the same model can be replicated around the world or any type of organization working within the aircraft maintenance atmosphere.
And the other thing that you told about that CAMO and maintenance, repair and overhaul. I think
Yes, sir.
Universally, that is applicable, I hope.
Yes, sir. That is universal applicable because this rule applies because aviation is a regulation oriented industry. So rules applied all over the world are same.
Okay, thank you. And those are interested, they can ask the queries.
You're welcome, sir.
Any questions from audience? Sir, myself, Dr. Neeraj. Sir, total around 5,000 number of surveys you have taken, out of which around 4,000 surveys were taken from the management side only. So how do you
Yes, sir. Actually, this study is based on management things. So people who are working at the ground level. However, this survey was circulated to all of the people. These are the majority of respondents. So these people who have taken the management position, they are the best person to respond to my queries because they understand the significance of the aircraft maintenance turnaround time. They are holding a responsible positions, and because of their valuable their significance contribution to this study, so management, I believe that this is the good response anyone have ever taken based on aircraft maintenance.
Okay, thank you.
You're welcome.
Thank you so much, sir. Now I would
Thank
like
you.
to call the paper ID 93. Paper ID 93. I would like to request the paper ID 93 to please present. Okay. As paper ID 93 is not available, I would like to invite paper 112. 122. Paper ID 122. The paper title is Recent Development of Aircraft Engine Axial Flow Compressor, a Review. The presenter is Srinivas G. I would like to ask the presenter if they are ready with the presentation. Yeah.
Good morning, everyone. Myself, I'm a faculty, Srinivas from Manipal Institute of Technology, Manipal Academy of Higher Education. and this is a paper about a review article, recent developments of aircraft engine axial flow compressor. And the paper ID is 122. This is written by my student, Pritesh Pinto. He is a student of aeronautical engineering department. And I would be covering this review article with the consistent with 10 points about a little introduction. Basically, what's the problem statement that is an abstract with the followed by uh, the research methodology which is followed for this review article and the background, what are the development that has been taken up for a system design and optimization techniques and possible the summary of this research which has been done and what are the research gap which is essential for a person who wanted to likely to take up a research in the area of propulsion. And that is the main highlights of this particular article. And finally, concluding this article with the references. And coming to the agenda of this particular article is to increase the thrust of an aircraft engine. So basically, if you take an air breathing propulsion, if you take a non-air breathing propulsion, the main agenda of any of the propulsive engineer researchers is to increase the thrust. So how do we increase the thrust across the categories in both the air breathing propulsion and non-air breathing propulsion? And coming to the context of air breathing propulsion, the rotating machinery, especially the turbo machinery aspects, are very much important for increasing the thrust. So that could be a turbo machinery component of compressor, or it could be a turbine or the fan in case of the turbofan engine. If that is a turboprop engine, it could be a turbo propeller. So these are the major essence of studying this review, especially the turbo machinery components. So whereas in the other side, non-air breathing propulsion, we are completely eliminating the factors what you are seeing in the air breathing propulsion. So the context here it is focusing on the rotating machineries, that is compressor and turbine. And however, there are advanced air breathing systems like a ramjet and scramjet engines are also available for taking up complex designs like missiles. But especially for an aircraft engine, someone has to focus on these turbo machinery components. Even still today, it's not able to produce enough thrust. What is the design requirement which is set by a designer? That is the primary objective of this whole study about in the review article. So in that, I'm categorizing on a compressor, which is a multi-stage compressor. That is what the overall context is about the review article which I am addressing here, and what further development that has been done and what can do further to increase the efficiency of a compressor. So coming to the forward thrust and rearward thrust, which is essential for an aircraft engine, that is done by the compressor or the combustion chamber, and whereas the rear end parts like a nozzle and the combustion chamber, therein you will be seeing the rearward thrust, which is actually focusing to increase the static or total pressure across the compressor, which I am highlighting here. So when I say the axial flow compressor, naturally there would be a two component that one has to focus on, that is rotor and stator of the given stage. So one has to focus much on especially the absolute velocity, which is matter with the transonic speed, where the modern aircraft engines are running with the transonic speed of Mach 0.8 to 1.2 and even 1.3 level, wherein absolute velocity has to cross from rotor blade to the stator blade. How it is emphasized to increase the significant velocity is most important. So that's where people are concentrating on stall margin, and it is a surge line, which is a major factor for a designer to focus and emphasize on, especially the transonic compressors. There are some attempts that has been done. This attorney and Lakshmi Narayana and India developed the design of their rotor and stator blades in the past 4 decades back itself, but the designs were failure. It is all because of one reason, that it is only the reason that the aerodynamics of the blades has not been considered with a great stall margin effects. So that's where the inlet guide has played a role to guide the complete flow as an aerodynamics across the rotor and stator blade, that too for a transonic region, especially when we go for a higher max speeds, the streamlined surface is much an effective mode of way of presenting it. So that's where the computational studies on compressor has been played a vital role in order to improve the pressure ratio, stall, and even the instabilities across the rotor blades. So there are some development that has been predicted across the compressor and turbine, that is with the 2D performance of the axial flow compressor. So it's very difficult for an engineer to resolve the issues, especially the viscous forces, that too with a Reynolds average Navier Stokes equation in 3-dimensional form. And there are some computational readily available tools we have, like a Fluent, CFX, Turbo Grid, with ANSYS, many other modules. But all that giving the readily available answers, just giving the boundary conditions. But one has to produce a real code across the viscous flow effects through a Reynolds equation, what we have daily deriving through a numerical computational equations, that is pretty less in the era of turbomachinery aerodynamics. One has to focus on such predictions across the rotor blade, which would actually emphasize to increase the enhancement of the compressor blades. That is where which we have to focus on. So far, what is being developed, the predictions much on 2D and 2D beyond with the AGAR 21 code, which is a kind of a Scilab code, and which is recently being developed even in the era of 2020. And there are some attempts which has been done, especially for a design of axial flow compressor for the last 4 decades, which I observe it to be very popular, that is viscous flow over a cascade and a group of plates analyzing it. And thereafter, people also calculating the tip clearance effects between the rotor and the stator blade, and rotor aerodynamic calculation, parametric design, and even the stator design calculations, and even the performance calculations across the breakdown cycle, what we study through thermodynamics of this engine, and even the optimized algorithms like response surface method, Euler algorithms, and so many other interface calculations also being done. But still, there is something which is not studying, that is a distorted effects which is not there in the transonic flow conditions, that could be addressed. And even in the modern aircraft turbofan engines also, people have studied these effects, especially that the interface effects between the compressor, fan, and even the through the shaft, how well we can able to produce that. But there are not studied much on the unsteady flow losses which is there in the compressor effects. That is where the optimizer techniques, which are like a gradient based technique, orthogonal array method, and response surface method, and artificial intelligence method, that can really emphasize to focus more further to increase the blade efficiency. For that, there are people who certainly have attempted the design aspects like wing design through the water plates, and even the centrifugal compressor, radial compressor, and even the blade enhancement through compressor blade, and increasing the cascade technology. This is what summarizingly, which we can put it across. The rotor to stator interface effects has to be studied in detail, and that has to increase even with the optimized blade, what we have seen today through the response surface methods. And the same calculation has been done for a 2D predictions abroad, but it is not unpopular to go with a higher number of stages, because as we increase the stages, naturally the interface effects will disturb the flow across the stages. That has to be studied in detail. That is where one has to focus on. So there are many predictions which can able to read with a static pressure, but dealing with the dynamic pressure across the stages, which is a quite challenging task for an engineer to resolve it. That's where one has to focus on blade profile from geometry to up to tip region, such that you can able to produce a very much great results to increase the efficiency of the engine in order to increase the pressure ratio. And there are techniques like active and passive techniques that can enhance the efficiency of the compressor. And also there are very less attempts has been made, especially for a transonic region, and one has to focus on. So that is where one can focus, and this particular article will definitely give us such an article to move on. These are the conclusions which I made through. There are 120 articles that I referred, but due to the place constraint that we have restricted to the page number limit of up to 85. Thank you.
Thank you. Okay, very nice review. Ultimately, you have accommodated to 60% article
Yes, 85 has been
because of the.
done. Arjun.
So I have one small
Yeah.
doubt just to have some clarity. I think you told about air freezing and non-air freezing system. They also got it as open cycle.
Yeah, Brayton cycle is same, sir, as you said, but the thrust requirements in air breathing propulsion is quite different through a rotating machinery than non-air breathing propulsion because we carry the propellant as a fuel along with the oxygen in the case of non-air breathing propulsion. Hence, you don't really require the complex aerodynamics what is there in the rotating machinery. That's completely eliminated. In fact, that's what even in the ramjet and scramjet engines are able to produce. But in case of aircraft engines, yes, one has to focus on these complex aerodynamics, how it is actually interfacing between the stages. It is required to study furthermore for a higher Mach number speed. Sir, this particular review article is mainly emphasizing aerodynamic complex designs, not focusing on materials side. Thank you, sir.
From audience? No. Okay, it was a nice presentation, sir.
Thank you.
So, I'm having one question only for my students.
Uh-huh.
Okay, so can you please explain one more time briefly that what is transonic compressor? How does it work? This is for my students only.
Yes, absolutely. See, when it goes to, someone can help me? Yeah, which I'm addressing for a transonic speed, which I said. See, a moment when I said subsonic to transonic, naturally the flow which is taking inside the engine that has to reach up to a mass speed of 20 kg per second. Just imagine with the revolution of your compressor speed of 17,000, which is there very detailed in my review article. Those who are interested can review that. And 17,000 RPM it has to rotate for a particular minute. And then only it can able to extract the 20 kg of air into the engine as I am showing in this animated video. So just imagine per second, you have to extract the 20 kg of air per second to reach that to for a max speed of 0.8. Imagine if you are likely to send such a massive amount of air into the engine when it is reaching to 1.2 and 1.3 and so on. Then naturally one has to see that the rotation, that the RPM has to increase, and you also have to see that the flow which is taking through this. And it is that and you have to send your heart of course, there are some articles on higher speed. I mean, beyond the subsonic, sonic, and transonic speed. That's where the present challenges which are facing in a jet propulsive area.
Thank you, sir. Thank you so much.
Thank you.
I'm sorry, guys. Actually, due to a technical glitch, we just lost connection with the 106, and now we have established successfully with him. So I would like to call the paper ID 106. The title is Fuzzy FMERA Methodology with Safety, Redundancy, and Diversity Considerations. May I call Rohan Saraswat?
Hello, good morning, everyone. Myself, Rohan Saraswat. I hope I am audible. Hello, am I audible?
Yes, sir, you're audible. Sir, can you please present your presentation?
Yes. Is it visible?
Yeah, sir, should we start the timer?
Yes.
Yeah, you can present right now.
Okay, so my topic is fuzzy FMERA methodology with safety, redundancy, and diversity considerations. So this is a part of my MTech dissertation research work, which was carried out at GTRE lab of DRDO, Reliability Engineering Cell of GTRE, under scientist F. Mr. Santosh, and was mentored by Shilal Sridhar sir, outstanding scientist H. So, as a part of reliability analysis, we usually in the design phase we usually do the FMEAs. We have DFMEAs. So, I'll start with the introduction. First of all, I'll tell you what all points we'll be considering. So, brief introduction I'll provide, then the history, and then why the fuzzy logic was chosen for the FMERA, and what's new in this methodology, how we do it, then validation and benefits, limitations, and future scope we'll be discussing. So, first of all, FMEA is failure mode effect analysis, and what I'm proposing is FMERA. So, that is a failure mode effect risk analysis. So that is a risk-based failure mode analysis. There people have tried these things, and previously the traditional methods that are there are suggested by various standards. So they propose RPN-based risk priority numbers. So those numbers are actually given rankings, and according to that, corrective actions are given. So what failure mode effect analysis does is it assigns the risk number based on the severity of the failure mode. So a system may have a component and it will be having some failure modes assisted with it. Let's say some leakage, some cracks may occur. So those are the failure modes, and it will have effect on the system level. Let's say an engine or the aircraft, or we may consider the environment also, or the user also. So like that, those will be the end effects. So it depends where we want to consider. So initially in traditional FMEAs, we were having three levels that we used to consider: local effect, next level effect, and the end level effect. So there are a lot of corrections that are proposed in the research work after going through multiple research papers and the standards, international standards that are there, and methodologies, latest trends. So after going through all the drawbacks, a methodology was constructed so that which can do more accurate FMEA, and even other reliability analysis can also be done. So there are different type of FMEAs are also there, which are used previously for different places. Let's say FFMEA is there, that is functional FMEA, used to see the failure modes in the functionality of a system. Then RFMEA, reverse FMEA, that is there, which is very good while going for the manufacturing part, manufacturing of the components. And this is very useful. Then FMECA, failure mode effects criticality analysis. So this can be done either qualitatively or with quantitative data if you have failure rates. Then EFMEA, that is equipment FMEA, and MFMEA, manufacturability FMEAs. Then design FMEAs and process FMEAs. So these are all the FMEAs that are done to find the effect and to reduce the level of effect, reduce the risk associated with the failure modes that can come either in the functionality, design, process, manufacturability, machinability, equipment use, operation, like that. So previously, these are the standards which were used to perform this analysis. So MIL standard 1629A, IEC 60812, ARP5. So all these were actually, I had studied, gone through, find the pros and cons, and constructed this methodology. Now, for this FMERA methodology, basically why it was chosen. So there were some reasons, because previously the RPN method was used, and some people started using fuzzy logic also to prioritize the corrective actions. So after getting the failure effects, we actually assigned ranking to it. Which one should be mitigated first? Which effect or which is the most serious failure mode which should be actually eliminated first? So how we do that? For that, this risk numbers were given previously. So they were found not that much accurate. Going through a lot of research papers, a lot of researchers have gone through that, and the fuzzy logic was the latest in trend, but also it was not suitable as per the standards. So, but it was very good. It gives automatic risk and action prioritization. Values are justified as per standards. Possibility of calibration of bias requirement, and also it can incorporate multiple levels of redundancy, safety as per the system or enterprise need. And also it is suitable for digitalization of reliability analysis. So we can actually link different analysis, other analysis other than failure mode, then safety analysis, functional hazard analysis, root cause analysis, that can also be linked directly through ontology. So that we'll discuss as a future scope it can come. Now, what's new in this research methodology is that a new fuzzy table and methodology was constructed to tailor the bias. So basically, while going for risk assignation, so some conflict matter. See, if we are having severity, occurrence, and detection rankings are given to a failure mode. So how severe the failure mode is, how frequent it is occurring, that is the occurrence rating, and then detection, how detectable that failure mode is. So if these three values are actually in some other way, in other combination, they are coming similar, and if you simply multiply them, so then again, what will happen is that we'll be getting the same uh, number, some the same risk. Usually, what in the RPN based methodology, they were directly multiplying it, but in fuzzy, we actually can give some bias to it, and this is very much effective while following the standards. So, standards suggest when a conflict occurs while doing the ranking through RPN method, then we should first give the priority to severity, which is having more severity. That failure mode should be mitigated first. Then with occurrence, so which is if that is also same, then we'll look on to the occurrence rating. So whichever failure mode is having higher rating of occurrence of the failure mode, then that will be prioritized, and accordingly the detection will be considered. So this is how actually some bias, if some bias is given into the output of the risk, then directly we can actually uh, have the risk value which will not be having so the confusion. Then the same RPN values or same risk values will not be having as an output. Okay, so this is the benefits of it, and some updates in the worksheet also proposed. And time-based, more appropriate detection table was given. And this is worksheet style documentation, fuzzy risk calculation. It refers to the, we can actually tailor the fuzzy tables according to our need, according to need of the enterprise. And risk values can also be compared, and accordingly the corrective actions can also be suggested. Now for the validation, you can see that the severity, occurrence, and detection ranking we have considered similar values. Basically, when you will directly multiply those, the RPN you will be getting the same. So you can see the first three on the left hand side, SOD ranking. If the severity is 8, occurrence and that is 8, detection is 2. So if you multiply it 120, then again same 8 to 8 and 288 if you consider RPN, you will be getting the same. So as per traditional FMEA, they say that whichever is having higher severity, you should prioritize it. So accordingly, we got the ranking. But when the same thing was considered with the conventional fuzzy FMEA, so those fuzzy FMEA that was proposed in previous researches were actually lacking the coordination with the standards. So they were not giving the same rankings. And when the system actually gets very much complex, then we will be having a lot of such RPNs that will be similar. So that is big issue. So the proposed FMERA can actually tag those rankings also. And it is very, we get at normal levels, normal problems at the civil is achieved from these standards. And at complex also it performs very well.
Sir, kindly wind
Now,
up.
the benefits are that automatic and appropriate. Yes, just a couple of minutes. So the benefits are that automatic and appropriate risk opportunity prediction is given, and dilemma of RPN clash is eliminated, and amelioratable as per the new standards and criteria which will be coming up in the near future. We can update the methodology, then provide systematic way to address safety and redundancy. So we can incorporate the redundancy if they are present in the system. Previously, it was actually not. There was no system to address the redundancies in the system. So which this can also be incorporated within this. And this better risk analysis and comparative risk values are better. And it can be linked to other reliability analysis tools also. If we talk about the limitations, then for initial system understanding and directly performing FMERA may not be felt or justified by design. So these are some limitations that they just would like to have some direct severity, like 1629A approach they would like to follow. But that is suitable for a simpler system, but not for complex system like that. And the theory of fuzzy logic on redundant system need to be proven in the real world. So we need to have some more data sets to understand. After doing the FMEA and getting the failure modes, we can also we would like to calibrate it. Now the methodology is based on qualitative analysis. Currently we are focusing qualitative, but it does not focus on physics of failure. So that is not considered till now, but that we can see in the future scope for accurate prediction. Now, if we talk about the future scope, then software platform we can go for ontology approach. We can
Kindly wind
integrate
up,
it into.
since like it's
Yes,
10 minutes.
just 5 seconds. Yes. So including the human factors, we can also incorporate into this methodology. Then it will become more and more accurate. So these are the future scope where this research can actually be elaborated into, and the trials to figure out a new methodology to get risk value with input of SO and D. Different methods can also be, other than fuzzy, we can also look into. And we can also try the quantification of risk. We can look on to that also. So these are some future scope and the references that I had gone through. Okay, thank you.
Thank you, sir.
Now I'm up for questions.
And answer
Yes.
question.
Yes, please.
Thank you, Rohan.
Yes.
It was a very convincing presentation. And you have mentioned in the slide number 8 from this one, RPN, some table presentation was there, in which I think in one of the columns, if you go back to that, there was
Okay, I'll share one second.
in inconsistency in the usage of the that is the values after the decimals. I think that can be I think some consistency can be there, particularly in that column about that RBN or something like that. I think will that be a problem to match or to maintain some consistency? Is it a system?
Yes, sir.
Yeah.
I actually did not understood your question, sir.
The decimal digits actually, can they be actually made consistent? Is it possible, or is it a
Like
that F
yes, sir.
RBN? The decimal points after the decimal point, digits of the decimal points, can they be?
Yes, sir. Those are calculated values, sir. Those that we are getting, that is through the formula that is running behind it.
And I didn't get what is that RPN clash that you mentioned, a dilemma about that RPN clash.
Yes, sir. So in the traditional FM, you can see the RPN values, RPN column in the traditional FMEA. RPN column, if you see, if we can get the same RPNs for different severity and occurrence. Basically, the same things if are arranged, we are directly multiplying it. So either you multiply 8 and 2, you will be getting 128. If you multiply 8 to 8, then also 128 and 288 like that. So this is actually the limitation of RPN system. So how we can prioritize it, because we know that if something is very if a failure mode is very severity is high, then of course it should be prioritized first, and then the second will be which is occurring more and more. So here we cannot give the same ranking, and we cannot mitigate all three at once. All three failure modes we cannot mitigate at once. That's why some ranking should be there. So there's a proper way that is given in the standards, and traditional way we cannot do it. Conventional also fails there, and the fuzzy methodology which is tailored right now, the table that is proposed, it is doing it fine.
Thank you.
Uh,
Any questions?
Thank you, sir.
Have you taken any real-time data into the consideration to validate your model?
So real-time data we can actually go for. I have written it in the future scope that, and also the redundancy scope, that this methodology is very much suitable for redundancies. Maybe in the real time, if we had gone through in the research and we would have gotten the data, then we might not be able to prove it. So directly I have taken the data where it will fail, where other systems fail. So testing it on the those points where the dilemma and airplane clash comes. So that was the first point, and I felt also suggested by my mentor that this will be the right way to validate or justify your methodology. And it was not just a justification. Actually, I had done multiple iterations to tailor the fuzzy table. Maybe I think it will be in 20-30 iterations were done to make that fuzzy table, calibrated as per standards to justify it.
And one more question, like you have mentioned this methodology is applicable only for the simple system, right? What do you
Which
mean
one, sir?
by this methodology in the future escape and the limitations? Like it is valid only for the simple systems. What do you mean by that?
Simple systems. No, sir. It is actually, my methodology is better for complex systems actually, because it directly gives. Otherwise, if we are going for a traditional one, so then RPN clash will come. We have to sit and see which failure mode is having higher severity, like that. So this thing does it automatically. Failure mode effect and risk analysis using fuzzy tables. So this specially calibrated table is very much accurate doing so. So complex system, you see that in points we are getting the risk values. So it captures even the small fluctuation in the risk.
Okay,
Like
fine. Thank you.
Yes, sir. Thank you, sir.
Next, I would like to invite paper ID number 32, and the title is Long Range Wide Swath Fast and Real Time High Resolution SAI Images Formation Using Digital Beam Formation. So, by Anupama Goswami.
Good morning, sir.
Good morning, ma'am.
Ma'am, can you share your?
Yeah.
Can you present your presentation?
Yeah. Is it visible?
Like, can you start the?
Yeah.
Can you start the time? Like timer?
Yes. Yes, sure.
No.
Good morning, respected professors and everyone who's listening to this. My title for the presentation is Long-Range Wide Swath Fast and Real-Time High-Resolution SAR Image Formation using the Digital Beam Formation. The topics that I'm going to cover will be as listed below. As per introduction, I've worked in headache data and in airborne detection, where they go back, that we cannot verify them in spotlight mode. We actually have been working on the strip mode and then converting it to the spotlight mode. That actually makes every of the time very delayed. So in real time, when there is any of the army or the air force is working, it takes time and there is a delay for that. To reduce that, we are using this method, as I've mentioned, the spotlight mode, there are two types of mode that I have compared in this paper. That is the strip mode and the spotlight mode. The spotlight mode, it obtains the high resolution image for the smaller area, whereas the strip map obtains the images for the wide, large, and the high resolution. The only problem in that is that it is blur, and to convert it consumes time. To omit this time processing, this is the paper that I am presenting to you. The problem statement, as I've addressed, that the spotlight mode will be used to overcome the limitations. Coming to the objectives, we'll use the small portion for the digital array transmission and capturing the echo of the large portion and on the reception side. So the gain advancement of the conversion of the receive echo and the digital beamforming. There will be multiple narrows at a different angle so that a large area is covered and we'll get the very image that is very clear by multiple stacking of it. This is the comparison. As you can see, the spotlight mode has highlighted the high and larger area. The parameters that I've compared is the swath coverage, resolution, antenna steering, image formation speed, array size, long range imaging, digital beamforming, and their advantages. The main that we are comparing here is the resolution and the array size. As we can see that the resolution of spotlight mode is high as compared to the strip mode. Strip mode do have the moderate to high, but for a very nearer range, for the long range. So that is a drawback of the spotlight. So digital beamforming is a process where there are two types of beamforming actually, the analog and the digital, but here we are using the digital because it is effective for the reception utilizing the sub-array element at the level conversion. Digital beamforming we use here for the multiple narrow as it is adaptable to different synthetic aperture radar mode. We'll enhance it for the long range and the high resolution imaging. I'll explain here by showing you my diagram that I have made for as you can see that there are multiple here. As you can see my cursor here, this is the angle. For single angle, we are making the multiple narrow beaming so that when the platform is moving in the direction, when the platform is moving in the direction of here, what I've taken is like 180 degree. So in moving in this direction, it can actually scan the area faster, and we can get the image of the area as fast as possible without going to the area where this task is being performed. So we are using the active electronic scanning array in this portion. The two parameters that we have worked on it as my thesis project, that it's a synthetic aperture length and synthetic aperture time. On that basis, we have made the radar cube, which actually helps in radar signal processing so that the image is being made. What we are using here is the LFM signals, that is the linear modulation for improving the range. And what drawbacks came in this is that there was a blind range that I haven't still overcome it. We can actually overcome it with different things. But in my process, there are like two drawbacks that I came. That is, one is the blind range when it was coming when I was using the up-chip signal. And second was the whatever the RAM we are using in the system. So it needs more than 16 GB actually. So these are the two drawbacks in this. This is my simulation result for stationary target actually. So we have done in minus 20 degree, 30 degree, and 50 degree. As you can see, simultaneously I have put it in the MATLAB, via MATLAB that I have generated. As you can see on right side of the graph, the whole of the part is not getting covered. That is a drawback that I have come with it. That there is a blind spot where we can overcome it, but due to the limitation of my PC, there was this. We can use it in the A1
airborne radars, and to the speed of what I have done is 230 kilometer per hour. We can actually go with per Mach also if it's possible. The upchip signals that we have used is actually very good for ECM and ECCM. Also, that we have used for image processing is that the match filtering is being used, and also the correlation is being used. We can use multiple algorithms in this. So we can also go for satellite time adaptive processing, and for the PFAs and backscattering and other things to be done. The conclusion on this was that there is effective use of wide and frequencies, that is the linear frequency modulation signals, and can be used for the frequency band as per the need. So what the testing is being done is showed to me is for the X band, that is on the 10 gigahertz, and also on the KU band, that is the 14 gigahertz, that we got a very clear image. We couldn't go to, we even did the testing for the car band, but for the car band the image was not clearer, so we have to change the parameters and the matrix as per it. So we can also use the platform motion compensation, that is roll, pitch, yaw, and then work on it. We can also use the adaptive Kalman filter, or you can say any adaptive algorithm or adaptive digital beam forming, so that we can track the target what we want to track. So these are my references. Particularly, I have used these two books, that is the digital signal processing for synthetic aperture radar, and obviously, yes. And this is these are my references. Right? Thank you. Any question and answers?
Can we start the question and answer session?
Yes, sure.
Hello, ma'am. Am I audible?
Yes.
Hello?
Yes.
Ma'am, can you please tell me the limitations of your work?
So the limitation of my work actually depends on the RAM. The RAM and the processor, what I am using right now, what my PC is like till 16, what I can afford. I have worked on my thesis in LRD. There we checked in 15 GB. So the workstation that we were using, so I actually can't take the data that was the real time processing was there. So whatever I could do in my PC is here, as you can see. So the limitation is one, is that the RAM should be very large. Second, the limitation is that the blind range was what happens when we process the image. There is certain portion of the blind range where we cannot detect the target. It's blank. It's totally black when we actually process. So that part is the limitation. We can omit it by different methods, but I couldn't do it at that time. So
Okay, and you have
these
shown
are my
the
limitations.
simulation data. So is it validated with the real-time data or not, ma'am?
So I can share here the exact real time, but yes, it is the real time data only. But I have manipulated the data a little bit. Manipulated, it means the data that was given by the scientist is not the accurate. I have used my own data to generate it. Yes, sir.
Thank you, ma'am.
Yes, sir.
Questions from the audience?
Any other questions? Is it there?
Okay, thank you, madam.
Oh, thanks.
Thank you, ma'am.
Okay, so next I would like to invite paper number 66. The topic of the paper is controlling down using mountable net mechanism. And the author is Gagana Babu Naidu.
Good morning, everyone.
Yes, ma'am, we can hear you. So should we start the timer?
Yeah, sure.
Ma'am, share your screen.
Mhm.
And can you please present it? Should we start the timer?
Yes. Is the presentation visible?
Yeah.
Okay. Yeah. Good afternoon, everyone. So myself, Gagana Babu Naidu from Department of Aeronautical Engineering, Dhananjava College of Engineering. So here I am to present on the topic countering drones using a mountable net mechanism. So this project was a part of my undergraduate thesis. Where we worked in assistance with Dr. Rudresh M. and Chala Aerospace at Indian Institute of Science. We know that UAVs have transforming the market these days as they are compact and they can be used for various applications. They require less skill to operate as a result of which their usability is increasing daily. The introduction of intelligence to these systems can be an alarming sign for security and safety of people and places. So, counter UAV systems have evolved as a technology and technique to detect, track, and mitigate these UAVs. As a part of this project, we have worked upon one of the counter UAV systems, which will be presented in the further slides. When we look at the counter UAV systems, broadly they're classified into three types: jamming, spoofing, and active strike. When we go into jamming and spoofing, they majorly use a ground system, which will either use a radar or some sort of signals which will disrupt the host UAV's signals with the controller. Whereas when it comes to active strike, we can see lasers, microwave emitters, birds of prey, and net. The main disadvantage in the ground based counter UAV systems is that they have a limiting operating range since the system is fixed to a certain place. When it comes to active strike, the laser, microwave emitter, or the birds of prey can be dangerous to the surrounding. Hence, in this project, we try to look into the net-based counter UAV systems. The problem statement for our project was to design a system which can launch a net, and this system can be mounted to an existing drone, so that we don't have the additional task of building a drone for the system. So we took the dimensions of existing drone and we built the system around it so that we can track any UAVs using a net. This net can go and trap any one of the propellers of the drone and subdue it. So the project framework was like this. We investigated different UAV systems. We investigated different methods to propel the net from the mechanism itself, and design and fabrication of the mechanism, and we tested the mechanism at different scenarios to check its functionality, and further efforts were made to optimize the mechanism. So this was the block diagram of our mission. The initial target we set was to make this mechanism work till 5 meters from the host drone, and the maximum we constrained the maximum weight to be 2 kgs, and we used a square net. So here in the figure 2, we can see the mission profile where we have this net launching mechanism. 103 represents the propulsion mechanism, and 101 represents a basket. We took it like it is in such a way that will be since the net has 4 different corners. We thought of attaching dead weights to the 4 corners and put it in the basket and launch it from the drone. So to first task was to come up with a propulsion mechanism which can propel the net. So the team looked into the electromagnetic propulsion, springs, jumper, and gas propulsion. The major limitation of the electromagnetic propulsion was the weight of the magnets. And when we investigated the spring mechanism, the springs which can store tension and launch the dead weights out of the basket. The problem was the synchronization of all four dead weights at a time, and and we were not able to come up with the solution to estimate how much energy was stored in all of these springs. So further, we looked into the jumper mechanism, and the gas propulsion focused on compressed air and carbon dioxide, which is presented in the further slides. So to initially estimate how much range we can achieve, we ran a MATLAB code where we gave our initial design parameters, and we saw that the mechanism can move up to 11.9 meters. Firstly, we started with the jumper mechanism for propulsion. So a jumper mechanism consists of four unidirectional carbon fiber strips attached to a barrel using two hinges, and these two hinges are connected to a string to a servo motor. So once the servo arm is toggled, the tension in the unidirectional carbon fiber strips will be released and will propel the dead weights out. This dead weight in turn, which is connected to the net, will propel. So the idea was to have four of these mechanisms to propel the net. We performed ACP analysis on ANSYS to see and compared commercially available unidirectional carbon fiber rods to test the reaction force which was being given from them. We observed that a reaction force of 11.9 Newton was being provided from one carbon strip itself. So we would be considering 16 of them. But the main issue was we weren't able to find a manufacturer who sells these unidirectional carbon fibers, and the structure was as we analyzed the system, we understood it was going to be a gigantic structure, and this system was proved for horizontal operability, and we weren't sure like how it's going to perform when we are going to launch it vertical. So second system we investigated was a carbon dioxide propulsion, where we'll use a carbon dioxide canister, which is commercially available, and we built a casing around it. So we used a model rocket stability, which is part of Barrowman equations. So the system was designed in such a way that it offers the canister the stability. At the same time, it will maintain the path and eject the net. Initial tests were run using a normal PVC pipe, where we attached the canister into the casing, and we blew it using a piercing nail. But the major challenge was the canister, though it was stabilized by the casing, it was not maintaining a straight path. It was wobbling inside the pipe itself. And further, it was causing, so as a result, we built a trigger mechanism which can restrict the movement of the casing itself. But later, the team saw icing issues from the carbon dioxide as it was stored for a month. We started to look at different mechanism which will offer us better functionality. So then we looked into the compressed air propulsion, where we have a tank in which we'll use the gas, and where the gas was pumped into the tank, and we used a normal ball valve to circulate pressure in all four pipes. Dead weights will be attached to the four different pipes, and net was placed in the middle. This was a basic prototype to test the functionality of the carbon compressed air propulsion, and we were able to achieve a range of 6 meters roughly. So here are few clip art from our testing phase. So from the test, we were confident that we will be able to achieve the desired range of 5 meters, and further, the different tests proved that the compressed air propulsion was reliable for this countering drone system. As a result, we moved ahead and optimized the mechanism. Instead of a ball valve, which was heavy,
Please kindly wind up.
we used a solenoid valve, and instead of a splitter to attach the PVC pipes, we designed a distribution manifold which was later 3D printed. And instead of PVC pipes, we used carbon fiber rods. This was the final system which was built and tested. So these are the final testing videos. From this project, we were able to design the mechanism which will launch up to 4.5 meters rather than the intended 5 meters range. The major issues which were caused, limitations were the bends in this mechanism, which was making us lose the pressure and reduce the range. Further, this project can be analyzed to come up with techniques to reduce the pressure loss and increase the range, and also make it better, like compact in size, so that we can reduce its weight, and we can fit it into a drone. Yeah, thank you.
Thank you, ma'am. Can we start the question and answer session?
Madam.
Yes, sir.
Yeah, I think one or two small queries I have. You have tried both with PVC and carbon fiber rods, you told, right?
Yes, sir.
So, what are the pros and cons of one over the other?
PVC, it has a bigger, the thickness of the pipe itself holds lot of pressure, and that was the major advantage for PVC, whereas carbon fiber rods were thin. The disadvantage was the PVC pipes, they were heavy, but the carbon fiber rods were less in weight.
Any weight comparison is there?
Yes, sir. We have presented the weight comparison in the paper.
How many percent I think from living off weight is achievable with carbon fiber replacing the PVC, something like that? As a whole.
Can you please come again, sir?
Is any percentage weight saving that could be possible by replacing the PVC with carbon fiber rod, something like that?
Yes, sir. We were able to reduce it by 30%.
Then you told about the compressed air storage prototype.
Yes, sir.
Right? So any specifications of the air pressure that was used there?
We finalized with 100 psi to from 100 psi, we were finally able to achieve 4.5 meters, sir. 100 psi, sir.
In bar, I think.
Just a minute, sir. I guess it's around 50 bars. Yes, sir. Sorry, sir. Just a minute, sir.
Yeah, I don't think. Okay, I think that is what some calculator I think is applied, because normally bar is the system in which we are normally moving to. So any questions from the audience? Yeah.
Hello, ma'am. Your presentation was really good. I have a question. Like, why did you specifically use CO2 as a gas for propulsion?
We wanted to go for something which was readily available. So that's the main reason.
Okay. Thank you.
Now, how did you maintain the pressure?
Uh,
Basically,
inside the tank.
that regulator you were supposed to use na, in that. So is it accurate to maintain the required pressure which is needed for that?
Like we were seeing some pressure losses at the end that is still being investigated.
Okay, thank you.
Thank you.
Now, I would like to invite paper ID 59, optimization of design parameters for fuel cells used in spacecraft. So I would like Mr. Vansh Bhandari to kindly present the presentation. IT department, are we able to connect to Mr. Vansh Bhandari? Okay, as we're not able to connect to Mr. Vansh Bhandari, I would like to conclude the session. As we conclude this enlightening session, I extend my heartfelt gratitude to session chair Dr. Mahesha GT sir and session co-chair Dr. Neeraj Gallot sir and each and every active participation. Now I would like everyone to request to proceed to the lunch. Thank you.